This lesson is on multiplying and dividing with numbers in scientific notation. Remember, numbers in scientific notation have a number between 1 and 10 multiplied by 10 to a power. That power could be a positive or a negative integer, like this one. Today, we're focusing on multiplying and dividing those, such as 4 times 10 to the third power multiplied by 3.2 times 10 to the negative 2 power. You may remember from earlier grades the associative property. The associative property tells us that if we're multiplying groups of numbers like a times b multiplied by the product of c times d, we can actually rearrange those factors and get the same product as an end result. For example, let's say that we're multiplying 5 by 14 and 2 by 20 and then multiplying those products together. I can actually rearrange the problem to make the mental math a little bit easier. So 5 times 20 would give me 100, 2 times 14, 28, and multiplying a number by 100 just means that we're moving the decimal 2 times, giving me 2,800, which is way easier than trying to multiply 5 by 14, 2 times 20, and then multiply multiple digit numbers together. We use the associative property to make multiplying numbers in scientific notation a little easier. We rearrange so that the powers of 10 get multiplied together and the numbers in the front get multiplied together as well. I multiply 2.3 and 7.9, and that gives me a product of 18 and 17 hundredths. Then, when I'm multiplying 10 to the ninth by 10 to the fourth, we learned in earlier lessons that we add those exponents to give us 10 to the 13th power. When we go to write our answer in scientific notation, remember we can only have one digit in front of the decimal. So I move this decimal here to give me 1 and 817 thousandths. But since I move the decimal, I actually have to make sure to add another 1 to my exponent, giving me 10 to the 14th power. Here's our first example for copying. We use the associative property to rearrange and multiply the powers of 10 by each other. So I rearrange 2 and 3/10 times 7 and 9/10. We've already determined to be 18 and 17 hundredths. Then I multiply 10 to the ninth by 10 to the negative fourth. When I'm multiplying and they have the same base, I add the exponents, giving me 10 to the fifth power. This would be our final answer, but our first number can only have one digit ahead of the decimal. So the decimal needs to move one place to the left, making this, instead of 10 to the fifth, 10 to the sixth. My final answer gives me 1 and 817 thousandths times 10 to the sixth. If needed, you could always check your work. Some people will get confused. Which way am I moving my decimal? Am I adding or subtracting to the exponent? So it's helpful to actually execute that 18 and 17 hundredths times 10 to the fifth out and compare that standard form to the answer you got, 1 and 817 thousandths times 10 to the sixth. Both of those answers in standard form give me 1,817,000, so I know that my answer is correct. For example 2, we have a division problem. We can separate this one out as well. 9 divided by 4.5 multiplied by 10 to the ninth divided by 10 to the negative fourth. 9 divided by 4.5 gives me 2. And then 10 to the ninth divided by 10 to the negative fourth gives me 10 to the 13th. Because remember, when we're dividing exponents that have the same base, we subtract each of the exponents, giving me a positive 13. For example 3, we have multiple steps in one problem. We have 9 times 10 to the ninth being multiplied by 2.1 times 10 to the negative second, all of that being divided by 4.5 times 10 to the negative fourth. The key is to take it in chunks, one step at a time. So let's start with our numerator. I rearranged my numerator so that the powers of 10 are being multiplied by each other. This simplifies to 18 and 9/10 being multiplied by 10 to the positive 7. Now, if this was our final answer, we would need to rearrange the decimal so it would be 1.89. But since it's not our final answer and it's simply our numerator, we don't actually have to convert it into proper scientific notation yet. We know that this whole thing is being divided by 4.5 times 10 to the negative fourth. To keep everything neat and tidy, I've rewritten my problem so it looks a little simpler than the long form that I had before. Now I can separate these out. 18 and 9/10 being divided by 4.5 and 10 raised to a power of 7 divided by 10 to the negative fourth. 18 and 9/10 divided by 4.5 gives me 4 and 2/10. And then 10 to the 7th divided by 10 to the negative fourth gives me 10 to the 11th power. So my final answer, 4 and 2/10 times 10 to the 11th power. Now here's one for you to try. Pause the video, try it on your own, play and check your answer. Ready? Here we go. The first thing I'm going to do is simplify this denominator. That is 8 times 3, rearranged, multiplied by 10 to the negative 2 times 10 to the positive fifth. 8 times 3 gives me 24. 10 to the negative 2 times 10 to the positive 5 gives me 10 to the third power. Now let's rewrite our problem to make it a little easier to follow. 24 times 10 to the third. Now that I have just a division problem, I separate it out. 7 divided by 24 and 10 to the fourth divided by 10 to the third. 7 divided by 24 is going to give me a really long decimal, 0.2916 repeating. Let's actually just round that to 0.29. 10 to the fourth divided by 10 to the third is just going to give me 10 to the first power. So when I go to rewrite this, you'll notice that I end up moving the decimal once and then taking the 1 off of the exponent, and I end up with 2.9 times 10 to the 0 power. But remember, anything to the 0 power is just a 1. So my final answer is 2 and 9/10.